If the flow of water is smooth, then different layers of water will glide past each other. They don't make turbulent eddies or splashes. A smooth layered flow is called laminar, which means layered. To generate laminar flow, we're going to create a nozzle that makes the water flow in smooth layers. Slow water is more likely to be laminar, so first we need to slow the water down. Second, we also need to remove turbulence from the water coming into the nozzle. And third, we have to direct the water into a laminar flow. We'll direct the water to be laminar by forcing it through 200 drinking straws. We'll remove the incoming turbulence by placing cheap scouring pads where the water comes in. To slow the water's flow rate, we'll just make our nozzle wider than the hose. A wide river flows slowly, but if you direct that water into a narrow gorge, it'll become fast. We'll reverse that effect so that fast water in the hose slows down in the wide nozzle.
Here are all the supplies in the order water flows through them. They will all be mounted into the pipe. First, notice the 200 plastic drinking straws. It's better if they're not flexible straws, but those were all we could find. You see a 1 foot length of 4-inch diameter PVC pipe. You can buy 1 foot of pipe at a time at many stores if you ask nicely. You'll need 4 yellow caps called test plugs. They should barely pop in like this. Make sure the test plug fits the pipe before you leave the store, as the inside diameter of PVC pipe varies. The ends of the pipe must be smooth cuts. The test plugs will be cut into 2 rings, then have holes drilled in them to make an inlet and an outlet for the nozzle. Here we show 2 different outlet ideas, a 1/2-inch drilled hole and a 2 1/4-inch drilled holes. Pay attention to the resistance your outlet offers to the water. Lots of small openings may have the same area as a large hole, but the water would have to fight against many edges. In this example, the 2 1/4-inch holes offer half the area of 1 1/2-inch hole, with more edge compared to the amount of open area. So if you use the same water pressure for the 1/2-inch hole that you do for a pair of 1/4-inch holes, you'll probably blow the pair of 1/4-inch holes right off the front of your nozzle. This is a male hose to female pipe adapter, a plastic part that can be screwed into the end of a hose. We'll use this to connect a garden hose to the nozzle. Adapters like this one are commonly sold at hardware stores. Plastic screen door or window mesh will hold the innards of the nozzle in place and may help cut down on turbulence within the nozzle. These are discount scouring pads. They cost $1 per pack and will be cut into circles that fit inside the pipe. You'll need 2 drill bits, 1 1/2-inch bit for an outlet, and a wider bit that matches the end of your hose adapter. You can cut the inlet for your hose adapter by hand, but you have to drill the outlet if you want a smooth stream.
Duct tape!
To test your nozzle, you can strap it together with duct tape. If you want to make it permanent, you can use epoxy glue, tiny screws, silicone sealant, metal strapping, and the like. But for testing purposes,
Duct tape!
Again, here's the photo of all the supplies in the order water flows through them. To turn 2 test plugs into rings, you'll need to cut along the inside of the plug. These plugs are made so that after a little cutting along the inside edge, the surface of the plug can be peeled out by adding pressure. We're using a folding knife that locks open. Swiss Army knives will often close by accident, so use those with care. Box knives are also great. I'm obviously not actually demonstrating this. We got so excited testing different outlets that we used all our test plugs, and at 50 cents a piece, we bought a lot of test plugs. To remove the lip of the test plug, fold the lip back with a pair of pliers around the circumference of the circle. Then, go back with the pliers again to pop the lid off. Any remaining chunks can be popped off or shaved off of the blade, and you'll get a ring like this. To shrink the ring and make room for the plastic screen, cut 1 millimeter or 2 of plastic out of the ring with scissors. Place the ring on the screen and cut around them, allowing an extra 1/2 inch of screen beyond the edge of the ring. When drilling holes in the test plugs, you don't have to drill all the way through. If you have a drill bit like this one, place the plastic on a piece of wood, drill into the plastic, then pop the plastic out. Any burrs or uneven edges will have to be smoothed by gently rubbing the inside of the drilled hole with the edge of a blade. For testing purposes, duct tape the hose adapter to your inlet, making it secure with tape on both sides. Place a plastic ring over a mesh circle and slide both roughly 1.5 inches into the 4-inch PVC pipe. It should hold the mesh firmly in place. Place both scouring pad circles gently into place over the mesh. Then snap the inlet test plug into place. You may need to tap it in place with a hammer. Flip the pipe over and add your straws, the bendy end down. It helps to add them in all at once, as the ridges on the bendy part will catch the edge of other straws. See, that's just really annoying. Gently tamp them down so they're all roughly the same height. Place the second ring over the second mesh circle and slide both down until the screen is resting on top of the straws. It should leave a large space between the straws and the outlet. Then, snap your outlet into place over the end of the pipe. To pop off a test plug, slide a fine edge, like that of a knife or metal spatula, between the plug and the pipe. Use the edge of your tool to lever loose the test plug. Go around the whole edge. Then, grip the lip of your test plug and pop it off. Finally, to test your nozzle, use tabs of duct tape on the front and back to hold the test plugs to the PVC pipe. Otherwise, if you use too much pressure, or the pressure suddenly increases, like when Ben covers the outlet with his finger, the test plugs will pop off, possibly shoot off. 1. The flow is spraying and dripping. This is a great laminar jet, but compare it to this one spraying all over the place. The difference is that the spraying jet has a tiny piece of plastic sticking out from its outlet, so small you can't see it unless you turn the water off and examine the drilled hole. By making sure the edge of the hole is perfectly smooth, the jet will also be smooth. If you use thick PVC end caps instead of test plugs, you may have problems making the perfect outlet because the water is traveling through a wide edge rather than a hole in thin plastic. 2. The flow is shaking. This isn't a problem with your nozzle, but a problem with your water supply. The pressure of water coming into your nozzle isn't constant, so the jet appears to wiggle or even turn into balls of water. One way to help this is to have the water flow through a tank with a layer of air at the top before it reaches your nozzle. The air cushion helps to smooth out the pressure changes. You may also have some air in your line. The original laminar flow head, designed by Dave Ayer, Mark Fuller, and Lee Sim in 1976, had an air release valve to deal with air buildup in the nozzle. 3. How do I make it cooler? Midnight Light Show.